Hello, and welcome to this Register webinar, which focuses on the intersection of network security and Wi-Fi. Now, successive generations of Wi-Fi have aimed at making the technology more resilient, more secure, and easier to deploy. But the evolution of Wi-Fi has thrown up almost as much complexity as it aims to resolve, complexity that's often costly and time-consuming for the market to manage. However, the good news is that progress is being made on a number of fronts, as we are about to find out. I'm your host, James Hayes, and I want to introduce our four expert speakers for this webinar. Heading up this quartet, we have Jonathan J.D. Davis, who is Product Marketing Manager at Juniper Networks. We also have Slava Dementyev, I hope I've got that right, who is Senior Product Manager at Juniper Networks. We have Kate Adam, who is Senior Director Enterprise Product Marketing at Juniper Networks. And we are also joined by Jennifer J.J. Minella, who is Founder and Principal Advisor, Network Security at Viszen Security. Welcome to you all.
Thank you.
So Jonathan, can you start us off with a little bit of Wi-Fi history? How have we arrived at the current state of Wi-Fi, and what have we learned along the journey to get here? Indeed, how did we get here?
Absolutely. I think this is an important conversation, and it really will kind of set, I think, the tone for the issues and ultimately the problems and what we're trying to solve today. When we consider the history of Wi-Fi, it was really interesting the way it was brought into most enterprise organizations. It was brought in generally by what we today call dark IT, right? It might have been VPs or C levels, or it may have been just a tech or someone who said, this works at home, and if it works at home, why can't it work here? And this was largely kind of driven by this explosion of devices that occurred after both Apple released their airport product that was kind of built into all of their portable devices, and then Intel kind of further expanded that with their Centrino line that was kind of this guaranteed, it was based on Wi-Fi standard. It was and it was kind of guaranteed, and of course that also came along with the marketing of Wi-Fi as a product rather than wireless 802.11, right? So there was kind of this kind of explosion of products that hit the market all at once, and people began using it at home, and then they began asking the question, why doesn't this work in the office? So Kate, I know you were around, involved in the space in that time as well. You probably remember this. The first issue, of course, was the fact that WEP was kind of the standard, the initial standard, and it was from a security perspective, and it was horrible, right? It was very easy, from the very beginning, everyone kind of knew, okay, this is not the way to do this, and so a lot of the standard answer from IT was, well, it's not secure, and even early on, that was kind of I would say IT security was in its infancy, but that was kind of what we fell back on, right, Kate?
Yeah, I mean, we were at a place where we kind of didn't know what we didn't know. We definitely wanted to prioritize, the access that Wi-Fi provided all of the users. And I remember even just from a user perspective, how difficult it was to even connect to Wi-Fi back in the day. And I had an Apple airport, and even that was, compared to now, just night and day in terms of complexity, and now kind of looking back, realizing the insecurity of WEP, and it is kind of shocking now. But at that time, we just didn't know. We were kind of, going through our evolution as not only a tech industry, but as, users of said tech, in terms of our, security knowledge and awakening, if you will.
Absolutely. And when we think about our clients at this point, we're talking about laptops. That was the wireless client, right? So, but there was also this concern of, well, someone can literally pull up into the parking lot of my building and get on my network. that's an issue. So there was kind of this early push to try to fix it with WPA. The problem was it still held on to TKIP. It wasn't a good solution either. But it was really kind of this bridge until 802.11i, which was kind of the first security standard that was part of the 802.11 protocol. That was kind of the thing that allowed us to then release WPA2, which happened. So you'll notice on the slide, 2003 was WPA, 2004 was WPA2, and it's pretty odd for you to see a second generation of something that come out so quick, but that was why. It also is interesting to say that we're coming up next year will be 20 years that we've been using WPA2. I mean, that's, for a security standard, that is phenomenal. Yes, there have been issues, right? We've had crack, we've had other things along those lines, but we've been able to mitigate it, and we've still been able to use WPA2 this long. So on one hand, I would say it's pretty amazing for WPA2. On the other hand, the second side of that is it's time for a replacement, right? there have been so many advancements. It's certainly time for a replacement.
Yeah, let's keep evolving. Let's keep getting better. Let's use stronger encryption standards, and let's make things easier, right?
Yeah, absolutely. So the other thing that kind of then happened over we'll look at the last 20 years. The big thing that happened was we had this huge transition from your normal Wi-Fi client, right? So initially we had laptops, as we said, right? And those are fairly easy to kind of verify, should they be on the network. They should be part of an Active Directory domain, right? In 2004, we were already into Active Directory. We were past NT. And so we can verify, are they part of in Active Directory? We can verify the client if the username is in Active Directory, and we've got, okay, some basic checking there. And then the assumption is we just put them on the network as if they were wired. But that begins to change because now there are new requirements, right? So now people are coming in for meetings, and they're going, hey, our laptops have Wi-Fi. Can you get us on the network so that we can present or we can do other things? So then we had this huge explosion of guests, right, Kate?
Oh yeah. And figuring out who was a legitimate long-term user who should have more than guest access, or access to everything that the network entailed. And then you had users who were coming in and out, right, coming in and out of the building, and don't even get started on when those devices became mobile, right, and automatically connected, or IoT devices started their big boom. And should they be allowed on the network? Well, they can automatically connect as well. So lots of guests, not just from a user perspective, but from a device perspective, and who's legitimate and who's not.
Yeah, absolutely. So we saw this transition. You're exactly right. So we saw guests. We saw, the thing is users, especially when they started their mobile phones, their mobile devices started coming in with Wi-Fi, they started putting them on guest, right? But they're not actually a guest. But enterprise also said, well, we actually want them to be able to connect to Wi-Fi, get email and those things. We want them to work for us on their mobile device. And so this BYOD explosion took place. And then directly after that, it was exactly as you said, Kate, it was IoT. So all of these, and each time we kind of upped the complexity of the device and more importantly, how to secure the device. And so that's kind of, that's the landscape of where we're working today. Lots of different disparate devices, lots of different capabilities for those devices. And each of those kind of needing a specific requirement, because they may be pre-shared key devices, or they may be .1x capable devices. And how do we verify not only that, yes, it is the device is able to connect, but if there's a user attached, they're able to connect. So that brings us, to today. We've got WPA3 that's been ratified. It was ratified in 2018. So for those of you who have heard a little bit about WPA3 and you're wondering, okay, is it real? It absolutely is. It was ratified in 2018, pre-COVID even. And then in July of 2020, it actually became, it was required testing for a new device to become Wi-Fi certified. So the WFA, or the Wi-Fi Alliance, said, okay, from July onward, for you to take a new device through our certification and become Wi-Fi certified and use that logo, you have to complete WPA3 testing. So any newer devices, it should be capable, right? So that kind of brings us to today. And I think it's important to recognize that, you know, WPA3 is here for a reason. And it's worth acknowledging as I said, the fantastic history of WPA2, but it's also it's also time to move on.
Yep. Bigger, better, faster, stronger encryption.
Absolutely.
Great stuff. Jonathan, can I ask a very quick question? I mean, I don't know if you're going to go on to speak about this, but what are the primary differences between WPA2 and WPA3? What advances or innovations were made there?
Absolutely. I'm happy to talk about that. You know, to do that, let's pull in JJ Minella. She is more than happy to talk about this, loves talking about it even, I would say, and we can start down that path.
Yeah, and perhaps you can tell us a little bit about, you explained to us where we've come from over the last 20 years and where have we arrived at? What's the current situation?
Absolutely.
Who'd like to start that conversation?
JJ, why don't you start?
You can just see me over here chomping at the bit.
Oh man, can I?
Hi everybody. Yeah, James, I love WPA3, and it is, like JD said, real. And I think Jonathan used a word a minute ago, and he said there was a phenomenal 20 years with WPA2 in the security space. I feel like phenomenally long and drawn out and painful, because we really should have been doing something different 10 years ago. So, you know, those of us that work in heavily in security, we're sitting here looking at this going, please do something, please do something, please do something. So big smile, because we did something, and I'm really happy about that. And to answer your question about what's different and what's changed, and, you know, WEP and all of the junk before WPA2 is so long ago. We're talking about 20 years ago. I don't even like to think about it. So I would just say, let's talk about WPA2, which is what most networks are running, to WPA3, which is what we should be running. And if we're not running it, this is the time to start considering that. And in a second, I'm going to kind of maybe ask JD to talk about why we need WPA3, even if you're in the situation where you're thinking, well, we don't really care about these networks at the moment. They're not going into critical assets. There are some other drivers besides just increased security. But for me, obviously, the increase in security is the big driver. And so we have, you know, three main buckets of Wi-Fi networks from a security perspective. There's the open network, which we think of for guest use and portals. There's a passphrase-based network where, you know, it pops up and you enter a passphrase to join the network. And then we have the enterprise networks, which are 802.1x secured, where we're using Radius and we're using EAP authentication to do really robust identity and authentication, and then possibly authorization. So out of those three buckets, I'm going to skip over the open stuff, although we have some interesting things happening there. The passphrase networks are really where the juice is happening with WPA3. And so, you know, for most of the 20 years we've been using WPA2 with passphrases, it's been broken. And you know, to kind of take all of the data and sum it into maybe 2 or 3 sentences, as a security professional, I just have to tell customers, if you have a WPA2 passphrase network using what we call a PSK, and it's called a PSK, pre-shared key, because the passphrase becomes the encryption key, which is a crappy model from a cryptography standpoint. Any PSK secured network cannot be considered secure. And the reason is because even with just basic, free, and inexpensive tools, a malicious user or attacker can actually passively just watch traffic, gather it, crack those passwords, and then get onto the network. So they can do a few things. They can get onto the network when they're not supposed to, and probably have access to a lot of other things in the environment, because these days, for the past several years, we don't have that peer blocking inside of the networks because of all of the Apple and consumer protocols. So that first risk is that somebody can get onto the network and then have access for lateral movement, which is a big no-no, especially in the world of ransomware. But the other piece is that they do also have the opportunity to decrypt traffic from any of the other endpoints. And not all of the traffic that we have these days is encrypted. It should be, meaning at the application level. So Wi-Fi aside, we're in the point now where a lot of the applications and services are all encrypted on their own. And so some people think, well, what does it matter? But the reality is it's not all encrypted, especially for in-house applications. So there's this opportunity where somebody can attack our network, have breached our network, and we wouldn't even know it. And WPA3 is a huge step up from that. So we don't have the opportunity for these passive attacks with WPA3. It has to be an active attack, which means we can monitor it and alert on it and stop it in process. And then there's all this other cool stuff that WPA3 brings with the passphrase, where there's a different algorithm called SAE, simultaneous authentication of equals, doesn't matter what it's called. Basically, instead of that pre-shared key, we have a different function which separates the passphrase from the encryption key. So even if we use the same encryption key over and over again, or same passphrase over and over again, they're different encryption keys. So there's all this cool stuff, perfect forward secrecy, where we can't decrypt other packets that were passed before. So if WPA2 security with a passphrase was here, we are just an order of magnitude and a whole different ballpark beyond that with WPA3. And so my message to everybody is, do go ahead and do that. But I think probably in a minute, we'll talk about why it's not that easy. The other piece is
real quick. So I think I want to summarize there, James, that is to answer your question of what's different, that is the major difference.
Right.
From a user perspective, it's the same. You're still putting in that pre-shared passphrase or pre-shared key. The experience from the user perspective is almost identical. It's purely what's the magic that's happening behind the scenes that creates that more secure environment. And while there is an improvement on the enterprise version of WPA3, the major change we see here is in the pre-shared key, the pre-shared passphrase, or the non-enterprise version that we use in enterprise all the time, especially for IoT and other devices like that. Go ahead, JJ.
Yeah, I was going to say on the enterprise side, with the 802.1x, there's some interesting things there that bolster security further. And I don't think it makes sense to dive into protected management frames on this session. But across the whole suite of WPA3, all of the different buckets, the open with the guest, the passphrase, and the 1x networks, we do have protected management frames, which is also a huge bump in security in terms of just the integrity of the infrastructure interacting with the endpoints. So that's, I think, the other really big thing.
So the big question that comes along with this then is how difficult. So if the user experience is the same, right? If they're entering their username and password like they have in the past, or they're entering a pre-shared passphrase, pre-shared key like they have in the past, what is the big difference, and do we have to test it going forward? And the reality is yes, we do. So then the question becomes, okay, how do we test, doing this transition, how do we test our clients to see, okay, can they support WPA3?
That's a great question, and it's loaded. Anytime we have any type of version overlap, so version 1 and 2 of something, 2 and 3 of something, we always have a mechanism for some type of backwards compatibility so that we can support the endpoints or the users that aren't quite up to snuff with the latest security, whatever. And the same is true for the Wi-Fi security suite. So we have something called transition mode. And I'm going to, if you envision this, transition mode, give it a capital T and a capital M, because it's a It's an actual mode of operation as defined by the Wi-Fi Alliance. And what that does is it says we can set up a network that's WPA3 secured, but we will also let those WPA2 endpoints join those networks. And we can do that, again, for the 3 different buckets. We can do open, we can do passphrase, and we can do 1X that way. But here's where I think, kind of rolling back from, Kate's recollection of the early days with some of the, just joining the networks kind of felt clunky originally. We've gotten just orders of magnitude more complex than that now. So, the whole just typing in a passphrase or a PSK, all of the junk happening on the back end at this point is so complex. So the user experience might not be that different, or they may not notice it at all. But the administration from the organization standpoint on the back end of this is just unimaginably complex right now. So that transition mode where we're letting version 2 and 3 of the security suite happen sounds like the perfect way to move the organization forward. But the problem is not everybody plays nice with that. And so we have endpoints that I call it misbehaving. So they're not operating with the IEEE standard for 802.11 the way that an endpoint should, which is they should, if they see something they don't understand, just keep going as long as there's a network being advertised that they can understand and connect to. So if we take foreign languages, James has a lovely accent. Slava has a lovely accent. You guys probably speak other languages. I'm going to go with French and Spanish though. So if somebody advertises something to me in English and French and Spanish and maybe German, and I might look at it and go, oh, well, I understand the English instructions, so I'm just going to follow that and keep going. But these misbehaving clients look at that and they see the 4 languages and they go, ooh, I don't speak French. I don't know German. And they just stop. They don't even try to associate. That is a misbehaving endpoint. It shouldn't do that, but it does. And so what happens is when you have a network that's advertising something an endpoint doesn't understand, it just kind of spazzes out. It stops trying to associate and it never connects. So we have to be very intentional about how we get from WPA2 to 3 because we don't know ahead of time which endpoints are going to misbehave. You just don't know.
Can I ask a quick question? Do we actually have the tools to enable end user organizations to manage the transition from WPA2 to 3? Is help available to manage that extra complexity that you've just been describing? That's an open question for JD and JJ.
I think we're getting there. I think it's a little slower than we want to be, but with this complexity, because the worst of this happens on the passphrase networks. That's where the worst of this happens, like 10, 20 times more than 802.1x network. So the complexity of that, with the addition of MAC randomization being the standard happening from IEEE, where endpoints may choose to just change their MAC address randomly so we can't track them for good purposes as well as bad purposes. All of this is just leading to the industry saying, okay, we need to do something different and better. But we can't keep relying on these kind of kludgy ways of authenticating and authorizing. And so we are trying to get any and all endpoints that can do 802.1x to be doing 802.1x so we don't have to rely on passphrase networks. Okay. I think the challenge for a lot of organizations, having worked in that space for about 15 years, is that everybody thinks 802.1x is very complex because you have all of your normal stuff, plus the radius, plus the authentication servers, plus, and you just keep piling these different things that are bolted on. Most administrators of the networks don't understand the operations and integrations of those discrete pieces, and they just kind of fidget with stuff until it works, and then they try not to touch it again so they don't accidentally break it. And so that's where we've been with this.
So for the sake of time, real fast, I want to pull us back to kind of our testing options here for WPA3. you've got a great slide that you created. Are really our three options here. As you mentioned, use transition mode. Do you recommend transition mode?
On a personal network, which I think is what we're looking at, on a personal network, I do not like transition mode because you don't know which endpoints won't make the leap. So, and even if you do change the knobs and you have endpoints that do support that, sometimes they still require manual intervention. So if you're going to have to touch an endpoint anyway, you may as well just put it on the new security suite if it's supported.
Okay. All right. So then that brings us to the other option is create a new SSID that is WPA3 and then transition your clients to that WPA3 only network, right? And ultimately that is the better solution here, because not only, as you said, you're going to have to touch the clients anyways, likely, you're going to know which ones fail in that process and you'll be able to address it directly. But you're also putting yourselves in a situation where someone can't perform a downgrade attack where they just go, well, this can do either, so I'm just going to force it into WPA2 and use the weaknesses that we know exist in WPA2, right? So this is really the correct, the better way of doing it if possible, right?
Absolutely, yeah.
All right. So if we start thinking about, so we've been talking about, .WinX, we've kind of, we've been talking about pre-shared key. If we kind of start thinking about .WinX, you mentioned, a lot of the overhead that comes on, comes in from the back end. And one of the things I've noticed is, especially when we start talking about Radius, which you were bringing up, and .WinX and that framework is it can become time consuming, especially in a large enterprise organization where you have multiple sites and you begin to start thinking about, how do you support either users overseas and that type of thing. And what ends up happening is you said it, people kind of fiddle with it until it works and then they just walk away. They're like, okay, it's working, don't touch it, right? And that's really kind of a common, even in large enterprise, that's a common occurrence. And I kind of jokingly refer to it as the ignore it. That's their method. It's the ignore it method. Another one that I see often, and I've worked in environments where it's don't touch it without the expert, right? So you contract an expert who knows that product inside and out. And then you just stay as far away from it as possible, unless they're on the phone with you or they're making the change themselves, right? And then of course the third way people handle it is someone in the team kind of takes the fall and says, you know what, I will do it. I will become the expert. Send me to training, give me the books, whatever is required, and they kind of skill up, right? And they become the expert on that particular product. But of course, while they're doing that, and even as they kind of take that on, that manpower, energy, and effort that they are kind of putting in is lost to that. And so the stuff that they were previously working on, generally that's getting passed off to someone else, or it's suffering. There's obviously a lot of issues that kind of come along with that. And this is what I've seen working, and I'm sure you've seen this as well, JJ. This is what I've seen working in a lot of really large enterprise organizations, from manufacturing, higher ed. I mean, a lot of different spaces where there's kind of this, everyone kind of approaches it with that same hesitancy that you were talking about earlier.
Absolutely. I mean, yeah, for 15 years, I would say I was that second person you described, which was like the expert in the different platforms, all of the different radiuses, all of the different NAC products. I mean, from like 18 years ago on. And it's hard. It's hard even when that is your full-time job. Yeah. So, because there are so many parts that are integrating together, if any one of those changes in any way, sometimes even a firmware upgrade, sometimes I don't want to say you're starting over, but sometimes you're starting over. So it's been very, very tedious.
Yeah, absolutely. So let's bring in Slava and let's start this transition and begin thinking about, okay, how do we fix this? Like, how do we how do we make this a little simpler? And I'm gonna pass it off to you two to have that conversation.
Okay. Thank you, JD. So actually, I want to go back to what JJ said in the beginning, right? So you have fundamentally three types of networks. You have an open network, you have a passphrase secured network, let's just generalize it, and you have a .1x with robust security. I think the one fundamental point here is to pick the right security method or network type for your use case, right? Because you always have guests, you have visitors, passerbys, your visitors to your enterprise, you have your IoT devices, you have your BYOD, meaning somebody bringing in their own personal devices onto their workplace, and you have your managed devices that your IT manages directly. You don't want to use one of these security methods for everybody, right? It's just not going to work. You want to put guests aside on an open network. You want to use a passphrase secured network for primarily IoT and BYOD, because at this point, you don't have to manage the end client directly. The onboarding is seamless from an end user perspective, yet you still have security. You have control over who gets on the network. Yet for the managed devices who generally get the most unrestricted access to your network, you want to make sure that they use the most robust security method, which is .1x. And with .1x, you can either use digital certificates as your identity, or you could use credentials, or in other words, username and password as your identification of that device, of that user. And again, as you both have said, with .1x, traditionally, again, we can look at all the history you've been talking about, JD, right? It started in the early 2000s when .1x was still there. It actually started long before we had Wi-Fi enabled devices on the market, right? It started with workstations that were plugging into the wired network, or even before then, when somebody was authenticating dial-up modem users. So .1x goes way back, right? And it started with all the AAA servers, all the radio solutions out there. And since then, they've been growing, they've been adding features, they've been adding new functionality, they've been supporting new use cases such as BYOD and guest. And now, 20 years later, we see all of the existing NAC products, they're like these beasts and monsters, right? You have this one server that has 1 million features on it. And as you said, people are afraid to touch it, right? This is where you go into these three different buckets of, okay, if it's working, I'm going to ignore it. I don't want to touch it. Or I'm going to pay somebody to do it for me, and I will do the finger pointing in case something goes wrong, right? Or I will become an expert, and some customers are actually, okay, I'm going to become an expert, but I still want to involve somebody from the side to do the professional services for me, because I still want to do the finger pointing, right? I don't want to be responsible for it. And this is not something you want to hear about the security product, right? You don't want to have that attitude towards a product that does a security for your network. So what we've been doing over the past couple of years is we've been trying to solve that complexity, right? How do we make network security? How do we make the most robust authentication methods, .1x, easy to deploy, easy to manage, while providing the visibility that we need to provide to a general IT admin, right? Because up until today, all these .1x, Radius, AAA solutions, whatever you want to call them, they are overlay products. They have never been integrated into your network. They've been standalone. You typically have somebody else doing it, and you have no idea what's happening when you're looking at your network, at your enterprise Wi-Fi network. So what we've been trying to do is, and we've actually done this, is we've moved all these infrastructure complexities, all these individual functionalities that you typically have in a AAA service up to the cloud. We provide this as a cloud native service that we manage, that we keep keep track of all the security patches, of all the feature upgrades, all of these things. And we make it an integral part of the network operations. So it literally blends into your network. So at this point, you could go and see, okay, let's look at the whole end user connectivity journey as it connects to the network, as it goes through this authentication process. If it's doing that one X, okay, I want to know everything about that user identity. Is that device using certificates or credentials to authenticate? What's the security context of that given user? Are we allowing these kind of devices on the network? If yes, why? If not, why not? And if something is not working, I want to know how to fix this. I don't want to, wait a day, a week, or months for somebody to fix it for me. And then after this is done, I want to see, is it actually on the network? Is it able to pass traffic? Is it having a good experience? Right. So this is what we've been working on with the access assurance service that we've introduced this actually last month already. And this is something that we've solved for the .1x specific use cases. And previously, for BYOD scenarios, for IoT scenarios, we have a service called IoT Assurance that's actually leveraging the passphrase-based authentication mechanisms, where we are solving the onboarding challenges for these kind of what we call either unmanaged or unattended devices when they're headless. So we are leveraging a concept that is called multiple pre-shared key, where you have one single SSID and multiple pre-shared keys associated with that SSID, where each pre-shared key becomes your identity vector, whether it's a Wi-Fi security camera, whether it's a Wi-Fi door lock that will never ever support that 1X in the first place, but you want to connect it to the network, you want to apply some form of control and policy on it. Right?
Slava, I actually had some questions about that. Because I worked in the 1X and NAC space for, like I said, a long time. And I kept hearing how easy this was, and I'm going, of course, yeah, well, if it is, it can't do this and this and this and this. Mm-hmm. And so the little bit of looking into things that I've seen, it actually kind of, like, my little ears kind of went up, and I thought, oh, maybe this actually does look like it might be this easy and do all of the things it says it does, which is very uncommon in the world of security. The marketing data sheet is nothing like the actual architecture when you get in and start doing it. So I think there's been some things I had questions about, and maybe some of the listeners have questions about here. Because I think when you talk about complexity, and even Kate, again, kind of rolling back to what you and JD were talking about at the beginning, it just exploded. So we've had issues where there's how we can manage and control an endpoint and interact with it. For a long time, it was in the enterprise, it was Windows devices, and we had that figured out. And then suddenly it was, okay, people are bringing their phones. But the Apple platform is managed on the back end very differently and secured differently than an Android platform, which both are then different from a Windows platform. And then we now have a lot of developers that are bringing Apple laptops, and we have Linux endpoints, and none of those are managed similarly. From an architecture in the operating system that hooks into the back end, we can't do the same things equally. So that's been kind of a mess. And I would also maybe challenge that, like, the managed devices. So I think, I've always jokingly said there's not just, internal managed devices and guest. It's kind of like 50 shades of BYOD, because it's, well, this group or department or business unit is doing this and needs this other access. And we have these contractors that need to do this thing and have certain privileged access into our environment. And then we have just the people that are walking into the space as guests, that are true guests. And then there's all of the other stuff in between those things. And so, it's not just black and white, us, them, inside, outside. There's, usually most organizations I would challenge, especially like you said with IoT, there's at least, even in a small organization, 6 classes of that rainbow of our internal stuff over to external stuff. And then the managed endpoints, again, we kind of started with everybody's got Windows, that's easy to do. But now within our own managed endpoints, we have these different operating systems that are managed differently and not centrally. So you've got you've got a heavy Apple presence, you're probably using Jamf. You've got Microsoft, you've got Intune. You've got stuff in the cloud, you've got stuff on-prem, you've got the phones over. So you end up with all of these different repositories. You end up with all of these different kind of sources of truth for identity and authorization. And maintaining the policies for that is unbelievably challenging. Because again, it would be easy if it really was us, them. But the whole dissolving network perimeter, dissolving user perimeter, dissolving endpoint perimeter, it's all just like this mushy, Play-Doh that's all kind of intertwined with one another that we have to untangle. And so I am kind of curious about the policies and how they're put in, because I know from troubleshooting this in the past, when I work with customers and I work with, it doesn't matter who's what they have, it's all the same to me. But it's okay, something's not working. You go through the normal checklist. What is this? What is this? What is this? And we have our normal thing, and then we look at this, and then we go look into the Radius server logs, and then we go over here. Like, you end up troubleshooting in 7 different places. I think is when I wrote the book on wireless security, and I had to make a little chart. I ended up actually, in part thanks to JD, I said, well, Radius is easy to set up for Wi-Fi. But then I started actually writing about it. I'm like, okay, it's really not that simple. And several people, so like there's a whole giant chapter in the book just on setting up Radius.
I wonder if I can jump in here and just remind speakers that we're in severe danger of overrunning our time. And can we use maybe the last 5 minutes that we have to decide, do you want to focus on speaking about the new solution and talking about that? Because we have been talking for nearly an hour now. So, Jonathan, what would you propose to do?
Yeah, I think JJ was setting up a great question there, but it was just a really long setup. Let's pass that over to Slava. And Slava, if you can just take the last few minutes to kind of get to the crux of her question, and which is, how do we handle VSAs? How do we handle these different these different clients? And remember that you are going to have that really short demo. So you're going to be able to show part of this, but just be certain that you're answering kind of the crux of her question.
Sure thing, JJ. So JJ, to start answering your question, right? So that's the whole reason why we wanted to build the access assurance service the way we built it, and we wanted to integrate it into a network. We didn't want for an end user or IT admin to go and log into product A, B, C, D, E to find out what is actually happening, why, for example, a certain device, say it's a Mac or a Windows, is not actually placed into the right network segment as it should be, right? Especially if it's different types of users, like employees versus contractors versus engineering versus finance, things like that. So, and in order to do that, we've actually, since this is a cloud service, it allows us to do all sorts of cloud-to-cloud integration. So we are talking to everybody, right? We are talking to your identity provider, which is Azure, Okta, whatever you might be using today. We will talk to your MDM, whether it's Intune or Jamf, or again, anything that you might be using today to manage your devices, et cetera, et cetera. So we have all these hooks and connectors into everything. But what we are doing with this is we are bringing that into that whole end user experience journey. So if we look at the actual demo that I'm going to show in a minute, this is where all these things come together. And let me actually stop here and go straight into a demo. All right. So what we see here, right, is the Mist dashboard where, again, as I said, we've blended in the access assurance service that's doing all your .1x authentication, the most robust secure authentication, with everything that happens on your network with your network ops. What we see here is the list of Wi-Fi clients, right? We're seeing what type of devices they are, where they're connected, which SSID, which security method they're using, whether it's WPA 3 or 2. But now what's important is how we look at the general end user connectivity experience. So if I'm going to click into this specific client, this specific user, if I look at the client insights, what we'll see is actually the whole history of that client on the network for a specific time period, whether it's, a day or a week period, et cetera, et cetera. And what we see here is how the client feels on the network, what's the user experience there as it connects to the network, as it gets an IP address, as it ARPs for the gateway, so we know that it's able to pass traffic. But now what we've done with access assurance was that we've actually extended that visibility into that whole authentication and authorization process. So we see, okay, client is doing certificate-based authentication. We then are doing an IDP lookup. That's where I was talking about this connector hooks. So we are talking in this case to Okta. So we know that this user is actually part of these and these groups. So we now know that this is an employee user, right? And at this point, we can say, we are admitting or allowing a client to connect. We are assigning a VLAN for this user. We're assigning a role, which is employee. And now we are saying which rule you've actually hit in your authentication policy rules. So if I'm going to click on it, it will actually highlight which specific policy rule that client went through during that authentication authorization process. This is how you blend in the two worlds together, the network and the NAC, right? This is to answer your question. How do you build your policies? How you connect all things together? This is how simple it is, right? You have a policy rule to say, okay, this is a wireless user. It's using certificates to authenticate. It's part of the employee group in your identity provider, and it has certificate issued by either of these two entities. And on the right-hand side, you're deciding what you want to do with these types of users, which part of the network they will go to, which role they will get. Easy as that. And we are ready. And if you would like to learn more about the Juniper Mist Access Assurance products and everything we've talked about, please follow the links that you see on the screen. There's a product webpage, blog, and the press release about the access assurance.
Okay, well, we've just about, unfortunately, used up our time for this register webinar. And I want to thank our expert speakers, Jonathan Davis, JD, Slava Dementyev, and Kate Adam from Juniper Networks, and not forgetting Jennifer JJ Minella from Viszen Security. I hope I got that pronunciation right. Thanks to all four of them for sharing their perspectives on the intricacies of network security and Wi-Fi with our webinar audience. We hope that you found plenty of insights that will inform and guide conversations concerning your own secure deployments of Wi-Fi, wherever that leads you. And so with that, until next time, it's goodbye.